idea of this basic idea of the electricity, we must understand what an electric charge is. We'll start by defining an electric charge as the intrinsic property of matter that of certain subatomic particles that make them interact between other subatomic particles in the way of attraction or repulsion forces. In a general way, we can say that a charge is a property of matter to exchange electrons. One of the most important characteristics of charge is that in any physical process in an isolated system, the charge is conserved. The sum is always the same of the charges, and this means that it doesn't vary with time. Another important characteristic of charge is that it is quantized. This means that there doesn't exist a flow of pure electricity. We can just think about a flow of quantized packages of electricity. This flow almost always represents a flow of electrons. And by historic reasons, electrons were assigned with a charge -1 or -e, as it is called sometimes. And protons were assigned with charge +1 or +e. These are basic ideas to understand what an electric field is. Let's consider a charge, a positive charge. In this case, we can consider an electric field as the portion of the space that surrounds this charge. And if one charge gets inside this portion of the space, this will suffer a force of attraction or repulsion depending on the nature of the charges of the system. The magnitude of the electrical field is given by the equation force that acts on the charge divided into the magnitude of the charge. The units for the electrical field in the international system are Newton per coulomb, or also can be volt per meter, or in the basic units, kilogram per meter per second and the -3 power per ampere at the -1 power. To understand mathematically an electric field, we can consider it as a vector. As you know, every vector has a direction, a magnitude, and a sense. The direction is given by the position of the charges. The magnitude is given by this equation, and the sense is given by the nature of the charges. If they are positive, there will be a repulsion. If they are negative, if they are the same, there will be a repulsion. If they are opposite, there will be an attraction. Sometimes when we need to represent graphically an electrical field, we can use these lines. These are the electric field lines, or just call it the field lines. And these lines are perpendicular to the charges. Go outside the charge if the charge is positive, or inside the charge if the charge is negative. So this way we can graphically understand what happens when there are various electric fields in a same system. And all these are just basic ideas to understand the electric fields. But this is one of the pillars of all the investigation and application of electricity nowadays.